Good morning, sir. Um, First, ginawa ko po muna yung problem 1 and 2 and I'm gonna show you how I got to this conclusion or answer. Let's first head on to the logically ng problem 1. So, makikita natin dito, sir, uh, yung ano rito, problem dito is tinur natin into a circuit. Now, sir, ang result ng Verilog sa number one problem is meron lang tayong output sa F if yung A natin is 0 and of course B is irrelevant. Now, since B is irrelevant, as you can see here, no matter what we do, it doesn't really change anything. The light bulb stays on, and even if we do this, the light bulb still stays off because the A is on and we need it to be off or not A in order to light it up. So the logically perfectly matches the Verilog. And now let's head on to the second problem. Now, the second problem. So as you can see here, the A this time is still relevant, of course, but B, however, as you can see, like in the first problem, B still doesn't matter in problem 2. It's irrelevant because no matter what we do with B, it doesn't change the output or the outcome. Let's discuss problem 3 and problem 4. The final answers are here in my PDF, but the explanation on how I got to them is of course in this video. Let's first check problem 3. So let's first look at the Verilog. No? As we can see here, if all switches are off, the light is also off. Now, if switch C is on, the light is still off. And if switch B is on, as we can see here, the light is on. And switch B and C, the light is still on. And if it's only A, the light is still off. Now, how about A and C? Uh, A and C is still off, and A and B still off, and A, B, and C. If it's all on, the light is still off. Now, as we can see here, it's only on if and only if this is the combination we have. Now, why do we think that is? It's because of the gates. As we can see here, we only need at least one, right? At least one. But if we switch A on, um, no gate activates because A is connected to both end gates and it affects both the gates. But if it's off, um, as long as B is on because it's connected to, of course, the B in B here, the light will always be on as long as the B is always on and the A is not on. So that's that for this problem. Now let's head on to this is just a short one, problem 4. Okay, so A connected to not A and output to A, not A and B. Now let's check the table. 0 0 is 0, and 0 1 is 1. How about 1 1? Okay, 1 1 is 1, that's correct. And 1 0. Now, as we can see here, the logically matches the Verilog code or output, and which means so far we've been successful from the first problem to the fourth problem. Now, why do you think that is? That almost A is almost irrelevant because no matter what we do with A, only the B matters. The light will stay on as long as the B is on, and no matter what we do to A, the light is unaffected by A. Now this is probably because of this not A gate, and of course, and this is an AND gate, so we need both outputs for this. but somehow we don't need the output from A if we switch on B. Why? Because if A is off, the not A is active, which means gate A and B is active and the OR gate triggers the light switch. Now let's head on to the next problem.